Hello everyone, welcome back to freepilotgroundschool.ca. This is our preparatory ground instruction on takeoffs, exercise 16. So there's actually 5 different types of exercises, and you won't be doing all 5 takeoffs and all 5 different types of landings all at the same time. There's something that are progressively covered in your flight training. So if you want to watch this whole video now, you can, or you can just watch, let's just say, the one section on normal takeoffs, because let's say you're just starting out, that will be the first one that your instructor will cover with you. And so you don't really need to know your short and soft field takeoffs until later. So obviously this lesson is important because, well, it's kind of the first big thing you want to do is take off the airplane. If you don't know how to do that, well, things aren't going to go too well for you with the flight. So let's begin discussing the pilot operating handbook. So if you recall back to section 2, preparation for flight, we talked about the pilot operating handbook and it's required to be on board the aircraft. And I also mentioned at the time that I will discuss more of it later in the lesson, and so will your instructor. And so this is a really good time to discuss the pilot operating handbook. So if you have a copy, you can go on freepilotgroundschool.ca and just download a copy of the Cessna 150 or Cessna 172 pilot operating handbooks. You can look through it, or you can buy one if you want a paper copy, or you can go through the one that's on the aircraft with your instructor at your flying school. So the manufacturer that publishes the pilot operating handbook will direct you how to do different types of takeoffs. And so it's important that you follow the manufacturer's direction because not every aircraft is exactly the same. For example, a short field takeoff or an obstacle clearance takeoff on a Cessna 150, the flaps are up. On a more powerful Cessna 182, you have 20 degrees of flap down, I believe. You do not need to memorize everything in the pilot operating handbook, but you have to be really familiar with it. You have to, if you don't know it, you need to know where to find it. And then, of course, there are things that you do need to know, such as gross weight, for example. So here's an example of pilot operating handbook. Let's look in section 4 of a Cessna 172, the amplified procedures. So let's just say I'm starting the engine and I'm wondering, geez, it's really cold out. It's the wintertime. Why isn't my engine running? It's like, oh yeah, I should have taken a look here. In warm weather, 1 or 2 strokes of the primer, and cold weather, up to 6 strokes of the power must be necessary. Okay, so here it gives you some information on cold weather starting. It talks about, if it doesn't fire and has black smoke from the exhaust, it means that you overprimed it. So these sorts of things are really important to be familiar with. And it's important to read through this whenever you're flying a new type of aircraft, because it will tell you all sorts of really good information. One of the differences, Cessna makes really good pilot operating handbooks. Some of the older models, like an old Piper Cub from like the 1930s or 1940s, the pilot operating handbooks are literally like 10 pages. They give you almost no information. And then I think like the Piper Cub, it's actually kind of funny. You can look through it and it's like there's like 10 commandments of safe flying, and it like channels the Bible for how to to fly safely. And it will be like, thou shalt not fly too low. Thou shalt not fly faster than your guardian angel shall fly, or something silly. And it's pretty funny. It's not very useful whatsoever. But somebody back in 1942 thought it was pretty funny. So you'll see that you can look that up online. So let's continue here. We'll take a look. And like I mentioned earlier, the pilot operating handbook will tell you exactly what you need to do. So for example, takeoff. It tells you here it's important to check full throttle operation early in the takeoff run. So that's a good thing to do. You apply full power and then just get in the habit of calling it out. Just say full power is, you take a look at your tachometer, say you have full power, make sure you don't have a rough or sluggish engine. Okay. So that's kind of right here. It tells you right here. And then it tells you, here's something interesting, and this is going to come up later in this lesson. Full throttle run-ups over loose gravel are especially harmful to the propeller tips. Okay. And I'm going to discuss this later on when we discuss short field landings. Okay. But here are just some sorts of things, how you want to do a takeoff. And then we'll discuss this again later on when we talk about short and soft field takeoffs. So first off, let's talk about the normal takeoff. The normal takeoff is probably what you're going to use most of the time when you're just taking off a typical airport. To do a normal takeoff, it's pretty simple actually. You can add full power. You maintain center line using the rudder, and you have your ailerons into the wind. And this is especially important, just having the rudder. So remember we talked earlier about, like during climbs, we talked about P factor and torque and slipstream. That airplane will want to go left. And if you didn't apply rudder, you would end up in the weeds. You'd end up off the side of the runway. And this is especially important on a tail wheel aircraft, that you apply, that you maintain the center line with the rudder. You're going to add right rudder. Okay, you're going to accelerate to the rotation speed. So on a Cessna 150 or 172, it's about 55 knots. You're going to rotate, so pull back gently to a gentle nose up attitude and climb at the desired airspeed. So typically between 70 and 80 knots. After you're at a safe altitude, you're going to do after takeoff checks. So the after takeoff checks are typically just going to be shutting off your, let's say, landing lights and taking a look at the engine gauges, making sure they're green. Might also be putting flaps up if you just happen to have flaps down for takeoff. I like to incorporate something called 3 things into my training. And these are kind of 3 things you need to do on every exercise that people always forget about. And they kind of make the difference between like a good flight test and like a really good flight tester. The examiner says, wow, this person really thought everything through. So these 3 things that you should do, I get in the habit of specifying a go, no go point and tell the examiner, like brief the approach and say, okay, I'm going to take off. If I'm not airborne by that light there or that intersection, I'm going to reject the takeoff because there's a problem. It's a good habit to get into. You're also going to have to make sure you check your full power and make sure your airspeed is alive. So as you're rolling down the runway, just make sure that you have full power and make sure that the airspeed's alive. So now let's watch a video of how to do a normal takeoff. Here we have a normal takeoff. We line up on the center line of the runway. We slowly add full power. Once full power is applied, we make sure that we have full power on the tachometer. And as we accelerate, we check the airspeed indicator to ensure that it is working. At the appropriate rotation speed, typically 55 knots in a Cessna 172, we raise the nose to a gentle nose-up attitude. After we're airborne, we can check our engine gauges, make sure they're good, shut off our landing lights, and complete the after takeoff checklist. So when I teach takeoffs and landings, what I do is I teach how to do a normal takeoff and landing, and then I just tell you how to modify it. So everything that you learned for a normal takeoff and landing applies for every other takeoff and landing, but there are just a few key differences. So now I'm going to talk about a crosswind takeoff and landing. So obviously the wind doesn't always blow down, straight down the runway, and you're going to have to take off in a crosswind. So you're going to do a normal takeoff, except what you're going to do is you're going to put your ailerons into the wind. And then you're going to use your rudder to maintain the center line. So let's take a watch of this video of a crosswind takeoff. And notice how, as we're accelerating down the runway, the ailerons start quite steeply into the wind, and then they slowly start coming out. And then we have opposite rudder to maintain the center line. A crosswind takeoff is very similar to a normal takeoff, but the wind will want to make you go off the center line. To control yaw, put your ailerons into the wind and maintain the center line using your rudder. After takeoff, the wind will want to blow you off the center line of the runway, so you want to crab into the wind to maintain the runway center line. Let's talk about a soft field takeoff. So hopefully you've gone solo, you've flown around, done a few circuits, and now it's time for the instructor to teach you how to do a soft field takeoff. So you're going to do a soft field takeoff whenever the surface is soft, and you need to get airborne at the lowest possible speed. So not the shortest distance, but the lowest speed, because the field might be bumpy, it might be muddy, it could even be snowy, and so you have to do a soft field takeoff. So you're going to do a normal takeoff, except you're going to put 10 degrees of flap down. So take a look in your pilot operating handbook, but in most aircraft, they will tell you to put some flap down. In the Cessna 150 and 172, it's 10 degrees of flap. In the 182, I believe it's 20. And instead of stopping when you line up, just continue rolling. Don't have everything prepared before you get on the runway, and just keep rolling. You're going to have full back elevator until the nose wheel comes off the ground. And you're going to keep the nose wheel off the ground at a slight height. So you're going to be at a gentle nose or medium nose up attitude. You don't want to hold full back elevator because you'll end up hitting the tail, but you do want to have enough back pressure that the nose wheel is off the ground. What will happen then is that you will get airborne at a very low speed. And when you get airborne, just think back, what kind of flight regime are we in? We're a high power, nose high attitude. Stall horn will likely be going off. We're in slow flight, okay? So then what you have to do is slowly release the back pressure. Don't push forward. Slowly release the back pressure and accelerate in ground effect, so about 5 to 10 feet off the ground until you're at normal climb speed. Once you're at normal climb speed, you can raise the nose. Once you're clear of obstacles, you can raise your flaps. So let's watch a video of takeoff here on a soft field and just kind of pay attention to the sights and sounds. Here's an example of a soft field takeoff. On a soft field takeoff, you're going to have the controls all the way back. In Cessna single engine aircraft, you'll have 10 degrees of flap. Accelerate and maintain a nose up attitude. Keep that nose wheel off the ground. Once airborne, release the back pressure, accelerate in ground effect to your climb speed. Once at climb speed, you can raise the flaps and do your after takeoff checklist. Here is an external view of a soft field takeoff. Notice the nose off the ground as soon as possible and the acceleration in ground effect until a safe climb speed is achieved. Okay, let's talk about the short field takeoff now. So the purpose of the short field takeoff is to take off when the runway length is quite short. So again, it's similar, the same as a normal takeoff, except you're going to use 10 degrees of flap, same as the soft field takeoff. And here's a point of contention, and I'll discuss this in a bit. The flight training manual says you want to apply full brakes and full power. And that's what you're going to be asked to do on your flight test. But recall your pilot operating handbook said you shouldn't be doing high-powered run-ups, especially on gravelly surfaces. And when we talk about short fields, it's pretty rare that a short field will be a paved runway. Nobody makes a paved runway that's 700 feet long. That's just silly. So most of the time, you're going to end up with a short field that's also, let's say, gravelly. Okay. So when you're flying with your instructor is going to tell you you have to have full brakes and full power before you start the takeoff roll. And yeah, that's fine. There's nothing wrong with that, other than it's going to likely damage your propeller and not be terribly effective anyway. And here's the reason why. So remember in your ground school, we talked about propeller efficiency. Most of your training airplanes, I assume, are going to be fixed pitch propellers. So they're not very effective at low speeds. They're most effective at cruise speeds, maybe a bit below cruise speed. You might even have a climb pitch prop that's most effective at 70 knots, but it's certainly not very effective at 5 knots. So you've applied full brakes and full power. When you let go of the brakes, you're not going to accelerate that much anyway because the propeller's not that efficient at low speeds. And so you don't really have that much better performance, but you're kind of ruining your propeller. So the only time that this really makes sense is, let's say you're flying a turbocharged airplane where you have to apply the power really slowly or relatively slowly, and a constant speed propeller, which is going to be efficient at low speeds as well. Then that would make sense to do. So anyway, it's not a safety issue, but I can tell you when I fly out of short fields, I never apply full brakes and full power because it makes very little difference, and it's just going to ruin the propeller. So anyway, I'll continue. You're going to rotate at the minimum speed as directed by the pilot operating handbook. So it's going to be around 50 knots or so. You're going to accelerate in ground effect and go to climb speed. So I'm going to show you a video of a short field takeoff out of a small, short field here, and you can see what it's like. This is a short field takeoff. Start at the extreme end of the runway, apply full power against full brakes, release the brakes, and let the aircraft accelerate. Keep the tail low and the nose wheel just slightly off the ground, and get airborne in the least distance possible. Lastly, let's talk about an obstacle clearance takeoff. So an obstacle clearance takeoff is a normal takeoff, except you're going to put the flaps as directed in the POH. So in a 150 and a 172, it's 0 degrees. In a Cessna 182, they tell you to put 20 degrees of flap down. You're going to do full brakes and full power, but we talked about it earlier, how I don't like that. Same thing applies here. And you're going to climb at the recommended speed until the obstacle is clear. So in a 172, it's 59 knots. In a Cessna 150, it's 60 knots. So again, consult your pilot operating handbook how to do this obstacle clearance takeoff. Once you're clear to the obstacle, you can put flaps up if you had them down and accelerate to the normal climb speed. At this point, you're probably wondering, well, what happens if I have a soft field, but then there's an obstacle at the end? Well, that's a really good question. So you kind of have to combine the two. And what you're going to end up doing is taking off in a soft field and then just climbing out at the recommended climb speed. And I'm going to show you here an airport that I fly into sometimes. It has quite a soft field and there's trees at the end. And just watch the video. In real life, it's actually kind of scary, but Cessna 150s and 172s have no problem getting in and out of here. But you just have to kind of be aware those trees do come up and can throw you for a loop. This is a takeoff over an obstacle. Apply full power at the end of the runway. Allow the aircraft to accelerate. Once airborne, climb at best angle of climb until clear of the obstacle. Once clear of the obstacle, accelerate to a safe climb speed. It is important that you maintain your best angle of climb and don't get afraid of the obstacle ahead of you and pull back below your best angle of climb speed. Doing so could result in a stall. Let's discuss some takeoff performance. So first off, we're going to discuss crosswind. This is a crosswind chart. It's out of the pilot operating handbook. And so you might be required at some point to figure out, well, what's my crosswind and headwind component? So you're going to pull out this chart and just take a look at the difference between your runway and the wind. So let's just say it's 50, and it's 30 knots right here. So you can see 30 knots at an angle or on an arc. Just draw a line down. So here, 24 knots is the crosswind component and 19 knots right here. Okay, so just basic trigonometry. If you're like a geek and like I am, so you can solve it with your sine relationships, but and cosine relationships, but or you can just look at this chart. Let's talk about takeoff distance. And again, you have to be intimately familiar with this pilot operating handbook by the time your flight test. So at this time, go grab your pilot operating handbook either online or if you have a copy and just open it to section 5, performance. And here we're going to look at the takeoff distance. So we've covered this already in your ground school, but it's worth a review. So first off, this is important. Look at your conditions, okay? Flaps up, full throttle prior to brake release, and paved level dry runway and 0 wind. Okay, so pretty simple. It assumes for all of them that we're at our gross weight. So we look at our temperature. And remember, we can interpolate between these two. If it's 10 or if it's 15 degrees, it's the average of these two. But let's say it's 10 degrees for simple. 10 degrees, let's say 1,000 feet pressure altitude. So again, you can interpolate between these two. And we just take a look. 1465 is distance to clear a 50-foot obstacle in 775. These numbers are pretty optimistic. That's what the airplane performed when it was brand new. And so it's kind of important to know you want a good safety factor. I would not fly this airplane if I had an 800-foot runway and I was at Crosswind. It's just too much. Can take a look at these different notes. So remember your maximum performance technique, section 4. So take a look at that. Lean your mixture above 5,000 feet. And then this one's going to come up often. Decrease your distances 10% for each 9 knots of headwind. Okay. And then with tailwinds, increase 10% for each 2 knots. So it makes a much bigger difference. And then here, this is good. If it's a dry grass runway, increase 15%, but the ground roll figure too. So I'm not going to work out the math. We covered that in the ground school already, how to do that. So just review that. Make sure you're confident with that, both for your flight test as well as when you're flying by yourself. Let's talk about some safety things. Wake turbulence caused by wingtip vortices. So we covered this again in our ground school. It begins with rotation, it ends at touchdown, and it's most pronounced when you have a clean, slow, high lift airplane. Helicopters have similar vortices as fixed wing airplanes. So you can see some nice photographs on the left side there, how these vortex go. And so when we take off, remember that wake turbulence avoidance is always the pilot's responsibility, although air traffic control should give you a warning. You want to wait a minimum of 2 minutes when taking off behind a medium aircraft or 4 minutes behind a heavy. And if you are approaching behind an aircraft, you want to approach high and touch down after the touchdown point. So avoid that wingtip vortex. And then if you're taking off behind an aircraft, you want to rotate prior to the rotation point and stay above the climb path. So what that means is, let's say you're taking off behind a 737, they will climb better than you. So ideally you're going to wait more than 2 minutes, but let's just say for whatever reason that I can't even think of, you don't want to wait 2 minutes. Yeah, you can do it, but you have to take off and turn out of the way and get out of that wingtip vortex. But that's a dumb idea. Just wait your 2 minutes and don't be impatient. So that's pretty much all I have to say about that. Let's talk about the flight test standards. So remember, you have to do a passenger safety. So just before you take off or so, just look at your passenger, your examiner, just be like, oh, your seatbelt secure, everything's good. Kind of look at the cargo compartment, make sure that's there. You obviously have to use your checklist, follow ATC instructions. And then I mentioned earlier, go, no go point. So you're not going to fail a flight test for failing to give a go, no go point, but it's the difference between a minor error and a perfect score. So just go for it. Remember that, point out to the examiner a go, no go point. Have your flight controls right, and then follow these the appropriate procedure for short or soft field takeoff. The one thing that I find often what students lose marks on is maintaining the center line. So if your fuselage is right over the center line, well, that's good. That's perfect. However, if your fuselage is off the center line, well, that's a minor error. And if your wing is off the center line, that's a major error. Okay, so keep that airplane in the center of that runway. And this is especially important when you start flying into smaller, narrower fields. Like anyone can land on a 200-foot runway, but unfortunately what it does is it creates kind of sloppy pilots. And then someday, I think the narrowest runway I've ever been into is like 15 feet. Like I couldn't even turn around. I had to manually turn the plane around. But I was sure glad I knew how to land on a narrow runway. That was in like rural Idaho 20 years ago or something. I was flying a Cessna 337. So just kind of be aware of that and just just keep the center line. Even after you take off, maintain the extended runway center line. Don't allow the wind to drift you off course. So that concludes this lesson on takeoffs. Thanks for joining me. We'll see you in our next lesson on circuits.